Hi everyone, welcome to our Tuesday class. Today our invited speaker is Dr. Fernanda Vasconcelos. She works at Federal University of Rio de Janeiro. She will speak about the annular modes. Fernanda, please, the space is yours. You can share your screen. You can
Let me share my.
Yeah.
Just a minute, people.
Okay. Your screen is okay. It's appearing for us.
Everyone can see this?
Yes. Just need to put in presentation mode.
Presentation mode. Okay. I have just one screen here, so I can't see the chat and the people.
No problem.
If everyone wants to have a question or interrupting for something, please say in voice and out loud, because I can't see the chat or the face of the people.
Okay. It's not in presentation mode yet.
Yeah. Oh,
Yeah,
here it
please.
is. And now?
No.
I will share the screen.
Okay. Share again.
And now you can see my.
Yes, we can see your screen.
And now it's okay?
Yes, perfect now. The space is yours.
Okay. Good morning, everyone. As Michelle Berboita said, my name is Fernanda Vasconcelos. I'm professor in meteorology department of Federal University of Rio de Janeiro. I will talk a little about annular modes. My doctoral thesis was about Antarctic oscillation, and its impact is in the South American climate. So it's my I am very interested in this topic, in this subject, and I will talk about both annular modes, the northern hemisphere and southern hemisphere, Arctic and Antarctic oscillation, but of course, I will talk a little more about Antarctic oscillation. This lecture will divided in introduction. I will talk about the definition, the indexes used to annular modes. I will talk about active periods and the whole of the stratosphere, connection with ENSO, influence on the synoptic systems, and how this Antarctic oscillation affects the climate in the South America, about how the climate models represent and predict southern annular modes, trends, and projections of both Arctic and Antarctic oscillation. Okay, starting with introduction. Everyone saw this definition of teleconnection in the other classes, in the last classes, but I will bring again. In meteorology, with the definition of teleconnection is anomalies occurring in one region associated with anomalies in remote regions. Bjerknes have a definition of atmospheric patterns response to a remote surface forcing. And Teleconnection is also known as preferred modes of low frequency variability. And we have a lot of teleconnections. You saw in the last classes about ANSO, North Atlantic Oscillation, multi-decadal oscillations like AMO, PDO, etc. And to understand and predict the climate, we need to know the impacts of these teleconnections. And we need that models, climate models, correctly represent these patterns and their influence. This is the big challenge for understand and predict correctly the climate. And here in Brazil, we have a big hotspot, the southeast and central east Brazil, the transition part between tropic and extratropics, have a very low predictability. We have a big problem here because, for example, for northeast, North Brazil, for South Brazil, we have relatively well-known the impacts of ENSO, for example. But this part, the transition between tropics and exotropics in Brazil, the impact of ENSO, for example, is not clear. So the predictability, the climate predictability in Brazil, in this part, it's not clear. And it happens in other places around the world. This part when we have a transition between tropics and exotropics. So we need to pay, normally in the climate prediction, the operational centers, people are looking so much for ENSO, the impact of ENSOs. But there is a lot of other teleconnections, as you have saw in the other classes, and that teleconnections also impacts the climate and also have influence on the predictability, climate predictability. So we need to pay attention on the influence of other teleconnections patterns. A bit of history. We had Sir Gilbert Walker. He has considered the father of the teleconnections, and he had extensive investigations into global scale oscillations, and found in this period of time, just a minute, you can see my laser here? The point?
Yes.
Okay. He found several large-scale pressure patterns in that time, and attempted to isolate useful predictors for long-term forecasts. He found temporal correlation of SLP, sea level pressure at several locations around the world, and discovered at least 3 large-scale pressure oscillations, and associated these pressure oscillations with temperature and precipitation anomalies. Besides these 3 large-scale pressure oscillations, he had a hint of other oscillations, even with low data of stations. These pressure oscillations implying changes in surface winds intensity or anomalous component of the wind intensity, the winds. And in 1928, this paper, he identified an oscillation-like pattern in pressure belt across Chile and Argentina with this pressure belt, it has opposite configuration, opposite sign, compared with stations in Weddell Sea, in Bellinghausen Sea, in the Antarctic, middle and high oscillation. So in 1928, he also have a hint, maybe there is an oscillation pattern between middle and high latitudes, but he can't affirm this because he had so little data. Decades later, with broader data of meteorological stations, the researchers can found these oscillations for both hemispheres. So the annular mode definitions is the oscillation pattern between middle and high latitude pressure belts in both hemispheres. We can see in this figure the polar projection, stereographic polar projection. Here is Antarctic, for southern hemisphere, Antarctic, and the continents, America, Australia, Africa. And here for northern hemisphere, Arctic and the other continents, America, etc. You can see the annular mode as a large-scale seesaw of atmospheric mass between middle and high latitudes. In Thomson Wallace in 2000 analyzed both hemispheres and compared this annular mode in both hemispheres. Until then, we call an Arctic oscillation, Antarctic oscillation, and people not compare these two. And in this paper, this classical paper, they compared these two modes and found the structure of both are remarkable, similar, and has some difference, but they are essential the same modes for both hemisphere, okay? And there was some indexes created to identify, and we can use for identify both southern annular mode and northern annular mode. We can call this SAM and NAM. The first index created was for Gong1, created by Gong1, and today it's called Marshall Index. It's using the pressure average for the latitude circle 40 and 65. So this term represents the pressure in this region, middle latitudes, and this part represents the pressure here in the high latitudes. So the positive sum phase represents positive anomalies of pressure in this region and negative pressure in this region, as you can see here also in this figure. And the negative, it's opposite. So negative pressure, anomaly pressure here, and positive anomaly pressure here. And there is a similar index for northern hemisphere. But we have advantages and disadvantages of this kind of index. This kind of index is simple to construct and easy to understand. But the zonal average may not accurately reflect the latitude configuration. For example, if you had this circle of latitude, this latitude circle, with in general, weak negative anomaly, but there was a smaller region with a strong positive signal area. So when we calculate the average, we may have a positive value and leave to understand there is a positive sum phase. But it's not true, because that is not positive in this circle, this latitude circle. So this simple representation may not reflect actually the sum pattern similar for northern hemisphere. Today, for most of teleconnection patterns, we use EOF, empirical orthogonal function, or some variation of these to represent the indexes of this teleconnection, and it's not different for solder annular mode and northern annular mode. So annular mode index using EOF. The EOF was applied for monthly mean, 8 anomalies, polar to 20-degree latitude, 20-degree north, and 20-degree south, 20-degree north, polar 20-degree north from northern hemisphere annular mode, and polar 20-degree south latitude for southern annular mode. The difference is in northern annular mode, we use 100 HPA level. And for southern annular mode, we use 708 level, HPA level, okay? So this is the representation of the leading EOF, the first EOF, using this configuration. So we can see here clearly the structure of annular mode, the positive phase of annular mode, and the principal component series here. We can see the index for, in this time, for example, we have a high positive value. So this means in this time, this day, this month actually, oh, this is the index daily, okay. This day, the represent field, it's quite similar of this. In this time, this here, if you plot the height anomalies, in this time we can see a field quite similar of this, but with the opposite signal, so negative phase. And for example, this time here, it's nearly 0. If you plot the field of the 8 anomalies, you see a completely different configuration. So that is not a representation, that's not occurrence of annular mode here. So when you use EOF, the value of the index is a representation of this configuration. So it's much more accurately than the first index here. But this index is used by Thompson Wallace in that study in 2000, and used by NSAP, NOAA, and the other places. But if you use the EOF polar 20 degrees south, 20 degrees south is still tropical region. So this EOF also, besides some, maybe this EOF also captured the tropical influence. Is that right? Maybe this EOF using this area, polar 20 degree, capture the EOF, the sun, and capture some signal, some noise come from tropical influence. Both hemisphere, but we are talking about southern, but we can solve this we can think this in both hemisphere. So my group studied and created an adapted sun index using the same methodology, but using polyward 30 degrees south. And we published this in this paper. And we can solve here the comparison between the traditional index and the index calculated southward, polyward for 30 degrees south. And this is the EOF using this adapted methodology. It's quite similar, the representation is quite similar, and it's better because we can solve the sum, the structure more clearly. Both indexes are high correlated. You can see it's quite similar, but the difference is the extremes when we have extreme signal. The tropical influence on the circulation patterns may be acting on the CPC, this red one, dumping the signal, and because there's some influence of the tropical phenomena here. But when we exclude the tropics using 30-degree polywatt, 30-degree, we can see only some signal, only extratropical signal. So we can see the extreme cases more clearly. So it's an interesting adaptation to made when we calculate this index, okay? About the active period, what is the active period? The annular modes for both hemispheres, here we are represent the southern annular mode, but we can extend this for both hemispheres, southern and northern annular mode. The annular modes exist year-round the troposphere, okay, with equivalent barotropic structure. What it means? What is it means? I'm sorry. We have the similar signal for whole troposphere. For example, if you see this in low level, middle level, high level, we can see the same structure with the same position of the centers, but with high intensity in the high levels of the troposphere. This means equivalent barotropic structure. But besides the troposphere, the annular modes can also exist in the stratosphere. And it's most pronounced in season periods when they are favorable conditions to have stratosphere-troposphere interactions. When these conditions happens, the signal of the annular modes can exist and has its maximum intensity in the stratosphere. The absence of solar radiation throughout the winter in the Arctic and Antarctic enhance the polar to equator meridional temperature gradient and strengthen the stratospheric vortex. And this helps to create the variability in the geopotential rates and create the signal in the stratosphere. Nonetheless, the interaction from troposphere and stratosphere vortex is only possible when the flow in the stratosphere is westerly, strong, but below a certain threshold. There is a paper in China Drace in 1961 discussing all this talk, how the configuration is possible to the wave energy from the troposphere to stratosphere, because in other configurations, the tropopause is kind of a lead in not permitting the troposphere connecting to the stratosphere. But in certain conditions, these connections happens, and when these connections happens, the annular mode can happen in the stratosphere and reach this maximum intensity. So in this period, we call active period. Here you can see a figure for daily mean 58 PA8, average for polar region. Each line of this is 1 year, plotted here, actually both 2 years here. So this is for southern hemisphere, and this is for northern hemisphere. As the geopotential, the temperature not varies so much in the tropic stratosphere. So when you see these, when you have more variation in the H anomaly, and remember the H anomaly is proportional to temperature in the layer. So when we saw here the more variation, it means there is more meridional gradient between pole and equator in the stratosphere. so it's a stronger polar vortex, so it's a stronger annular mode, okay? So if you see here in the Northern Hemisphere, the maximum variance here happens in the boreal winter, January, February, March. So actually so here we can see the activity period in the northern annular mode happens in this period. But for southern hemisphere, it's not happened in the austral winter, not happen in this July, August. It will happen in November, end of October and November. Here you can see a similar figure like that, and for southern hemisphere, and we can see here more clear, the maximum variance here happens in November, October, November. And we can see here geopotential H anomaly in 500 HPA, so middle troposphere, for positive sun, negative sun, January and November, inactive and active periods. We can see in troposphere in both months, the positive phase, positive anomalies in middle latitudes, negative anomalies in the pole. We can see it's here in November, and negative in both months. It's in the troposphere, but we can see the same figures for 50 HPA in January, an active period. We can see some signal here, but we can't see CSO between middle latitudes and pole. And in November, the intensity, it's much higher, and we can see negative here and positive middle latitudes, and the opposite configuration here. It's quite clear that in the stratosphere, this is when the signal of on the southern annular mode is stronger. So this figure show vertical section. This is pressure level and this is latitude for southern hemisphere, northern hemisphere. Here is for February, March, so inactive periods for southern hemisphere. Here is June, July, August, inactive periods. And here is November, and here is January, February, and March, active periods. This is zona wind, okay? You can see here in the inactive periods for both hemispheres, we have stronger winds restricted to troposphere, okay? We have the maximum here, about 200 HPA. But in active periods, the region of the westerly jets extends to stratosphere, because in here, in this period, we have stronger stratospheric jet, stratospheric polar vortex. So in this period, the active period, when we have a stronger signal of annular mode in the stratosphere, we have a stronger stratosphere polar vortex, okay? But why does the sun activity period does not occur in austral winter, but in November? What's happened because that in southern hemisphere it's different from northern hemisphere? And to explain this, we need to look for the whole of the stratosphere. That figure show zonal wind in 50 HPA, average 60 degree, polar 60 degree south. And we can see in the winter, the wind is strong, but it still continues to intensify, to strength into October. And only after this, we have a break of stratosphere jet, okay? Similar figure that show in the early slides for southern hemisphere, for northern hemisphere. This is 8 anomalies in 50 HPA. Remember, in this maximum, this is the line of the value in tropical region. So these points, the far points from the value in the tropical, we have the maximum temperature gradient between equator and pole. So we have the maximum westerly winds, we have the maximum stratosphere polar vortex. So the stratosphere polar vortex reaches this maximum during the winter in the northern hemisphere, but the maximum heat happens in October, for example, in southern hemisphere. And China Dracy, this is 61, explained for planetary waves in the troposphere. The vertical propagation of wave energy of these planetary wave energy is possible only when zonal winds in the stratosphere are westerly and below a critical value. This propagation of this energy from the troposphere to stratosphere does not occur when winds are easterly, like this, or when the winds are westerly but above a critical value, like this, only happen in this period. For example, in November, when the maximum of wind in the stratosphere kind of break down. In middle latitude, this energy cannot penetrate above middle stratosphere during the year when there are stronger zonal westerly winds or weak easterly winds above the tropopause. So the energy is trapped in the troposphere. And what happens when this energy of planetary waves can reach the stratosphere? These planetary waves has easterly moment. They are propagate easterly. And the jet in the stratosphere, the polar vortex in the stratosphere is westerly. So when this energy from the planetary wave reach the stratosphere, kind of have a break in the stratosphere polar vortex. So this propagation is responsible for diminish and breaks the stratosphere polar vortex. So in this situation, when this propagation happens here, the polar vortex can has lower value, and we had the maximum values of solar annular mode. Okay. Now we'll talk about connections of annular modes with ENSO, focus on the southern annular mode, and how these connections happens, because ENSO is a tropical teleconnection, and annular modes are extratropical teleconnection, but they are in a way connected through variations in the Hadley cell and in the mean meridional circulations. Also, the location of Rossby wave break in the Pacific sector changes markedly during ENSO events. So this influences the polarity of annular modes. Influences, for example, the jets, the westerly jets, and this influences the annular mode configuration. The potentially connected to variation of Rossby wave breaking and variability also modify the magnitude of polarward at moment flux and its convergence. And this alters the intensity and the position of southern hemisphere polar jet, especially in the Pacific sector, and this alters the polarity of annular mode, in this case, the southern annular mode. And this connection is stronger during austral summer, okay? So the studies, the papers show in El Nino years, we have more frequency of negative sun phases. And in La Nina years, we have more frequency of positive sun phases. This is not means that during all periods of El Nino, we have only negative sun phase. We will see some periods of positive sun phase, but the negative sun, it's more frequently in this period, okay? And we can, I will show in the next slides, in negative sun phase, we have intensification of, for example, subtropical jet. And in El Nino phase, we also have intensification of subtropical jet. So when we have El Nino and the intensification of subtropical jet and the equatorial part of jet stream, and this is favoring the occurrence of negative sun phase. That is related to intensification of subtropical jet of the equatorial part of jet stream. So it's current, these results. And the sun, here I will focus on the sun, the southern annular mode, has influence on the synaptic systems happened in the southern hemisphere. Here, looking for westerly jets. This figure shows a vertical cross-section, latitude, pressure level, and his is zonal wind in the line is in the contour, it's zonal wind anomalies, composite for positive sun phase and for negative sun phases. And we can see here intensification of westerly jets, the polar jet, or if you're looking for not separating polar and subtropical, but looking for jet stream, there's an intensification of the polarward side of the jet. So we can see positive anomalies. So we have a region of positive winds, zonal winds. We have positive anomalies, so it's an intensification. And for equatorial part of jet stream, or if you're looking separately polar and subtropical jets, so in the subtropical part, positive sun has a weakening of this part of jet. So subtropical jet or equatorial part of this jet stream. And in this part, we have the opposite. Sun negative phase has intensification of subtropical jet and weakening of polar jet. Okay. I put the explanation I just told. And influence of cyclones. This paper from Michelle and the other collaborators show the the cyclone densities for negative sun phase, neutral sun phase, positive sun phase. This column is for summer, autumn, winter, and spring. We can see here for negative sun phase, the cyclone the cyclone density extend for lower latitudes compared for positive sun phase. In positive sun phase, the the cyclones more restricted near the Antarctic. So the cyclone trajectories move northward in the negative sun phase when compared with positive. And it's current because in middle latitude, negative sun phase, we have negative anomaly of geopotential, negative anomaly of pressure. So it's favoring the occurrence of transients, the favor the occurrence of cyclones in the middle latitude. So it's current that in some phase, negative sun phase, we have cyclones happening in lower latitudes than compared with positive sun phase. And for protogenesis, the similar figure, negative, neutral, positive, and summer, autumn, winter, spring. We can see here the frontogenesis. And in general, this paper is focused on the South America and Atlantic sector. And we can see in general, the negative sun phase, we focus on here, autumn, negative sun phase have more intense frontogenic activity compared with positive sun phase. The tones here, the colors here are more red than here. So in general, you can see this in all seasons, but in autumn it's very clear here. So negative sun phase favoring more occurrence of frontogenesis in this area. And it's also current for the same explanation that I told about the cyclogenesis. So more occurrence of frontogenesis in lower latitudes. It's current with negative anomalies in middle latitudes in the negative sun phase. The influence of blocking. This is a paper from Monica Mendes and collaborators, 2013. This table is very interesting because show blockage days and blocking events for positive Antarctic oscillation, always Antarctic oscillation, so the annular mode, and negative Antarctic oscillation, both columns, and they studied the blocking occurrence for Southwest Pacific, near Australia, Southeast Pacific, near America, South America, and South Atlantic, for three regions, three ocean parts, three ocean regions. Blocking, it's an anticyclone. So we expected, for example, in positive sun phase, there is a positive anomaly, geopotential anomaly in middle latitude. So we expected in positive phase, sun phase, we have more occurrence of blocking or blocking days, because this blocking anticyclones happens in middle latitudes. And we can see this in southeast, the animation not happened, but we can see this in Southwest Pacific and Atlantic. Compared positive and negative, we have more blocked days and more events here also. But when we see this in Southeast Pacific, the event, Southeast Pacific, the Pacific near South America, the events is quite similar, a little more in negative phase, but 53, 56 is almost the same quantity. But when you see here in the blocked days is higher in the negative phase. Well, it's opposite for the other regions, and it's opposite what when we think about it. What happened here? In the Southeast Pacific, the blocking anticyclone normally used to happen in higher latitudes than compared with the other regions, more near the Antarctic than the South America. So the negative sun phase, what happens in the negative sun phase? The positive anomalies happens in the Antarctic. So in the positive sun phase, this blocking happens in higher latitude. It's influenced by this positive anomaly of geopotential near the Antarctic. This is not influenced so much in the events, but influencing the blocking days. So negative sun phase, the positive anomaly of geopotential in the Antarctic, favoring the occurrence of more blocked days in Southeast Pacific, because the blocking in the Southeast Pacific normally happens in the higher latitudes compared with the other regions. Okay? And influence of South Atlantic Convergence Zone is a main atmospheric system, meteorological system, related to monsoon, the South American monsoon. And the main generation of precipitation in austral summer in South America, and the sun influenced this system also. This is a paper from Ross et al., 2018, and they analyzed the South Atlantic Convergence Zone and the sun phases. And they show about 65% of SACS events occurred in some positive phase. And the SACS usually is longer in the sun positive phase compared to the sun negative phase. Okay? This is SACS events. We can see normally the red one, for the most part, is higher. Most months is higher. And here it's the duration, it's percentage of days. It's higher of sun positive than negative. So they with some explanation, because normally we have more occurrence of positive sun than negative, so it's influence the more occurrence of SACS in positive. This is box plot of persistent days of SACS for negative and positive sun. We can see here the SACS trend events tend to be more persistent, and their variability are greater in sun positive. And this is a composite of precipitation, accumulated precipitation during SACS events, and this is a difference between positive sun and negative sun. So we can see positive value is a key, and it means there is a higher accumulated precipitation on the climatological position of SACS in sun positive than sun negative. So sun positive influences more occurrence, more duration, and more precipitation of SACS events. Okay? But what about, we talk about the influence of sun in the different synoptic systems, and what about the effects on the climate in the South America? This is a paper based on my master dissertation. We focus on the extremely wet summers and extreme dry summers in part of Southeast Brazil. And this is a composite of geopotential anomaly for these extreme wet summers and extreme dry summers. And we can see clear here the signal of positive phase and negative phase. So Southeastern Brazil in summer, at least, has impact of some phases. And we saw, this is for positive extreme summers, like extreme wet summers in not southeast Brazil, we can see the signal similar to SACS, okay? And positive sun and PSA configuration. So there is a combined influence of PSA and sun to create this wet signal in summer, during summer in the SACS region. What happens here? We have a PSA, but if you can see here this anomaly, the cyclonic anomaly is strong, is high, and it happens because we have negative anomaly here in this region related to positive sun phase. So this part intensifies, strength the signal of PSA and strain the centers downstream, influence the continent and influence this configuration, okay? The positive sun amplify downstream centers over South America, favoring the occurrence or the intensity of SACS. This is another paper because we want to know the monthly impact, the impact of sun for each month, the positive and the negative sun phase, how this impacting the precipitation and in the temperature in the South America month to month. So this paper described this. We used the adapted sun index, polywater degree, and we had a composite for positive and negative sun phase, and we excluded years, answer years, because we do not want to mix the signal of sun and answer. There's a lot of results here. The sun influences are different for each month, and there are also difference between some phases, not always opposite, okay? But we have some general conclusions. In some months, March, May, July, August, September, November, etc., we have positive, this is for temperature, we have positive anomalies in negative, in Southeast South America, we have positive anomalies Southeast South America and part of Southeast and Central East during negative sun here, and opposite signal in positive sun. However, the coverage of these anomalies is different among these months. Here, it's different exactly from this, for this, for this, for this. Part of this coverage is Southeast Brazil, Central East Brazil, Southeast South America, but it's different, the coverage for depending of the month. In February and December, we have a dipole structure in the temperature with a positive anomaly in Southeast South America and negative anomaly northward in the negative sun phase and the opposite configuration positive sun phase. But in general, the configuration is quite different for the other months. We have positive anomalies here and negative anomalies here, quite opposite, not exactly opposite, but quite oppositely between some phases. And for precipitation, also the sun influences are different for each month, and there are also difference between some phases, not always opposite, even more that we can solve and can see in the temperature. Some general information of these maps. We have in November, December, January, March, summer months in general, we can see a weakening of sacs in negative sum phase, here with negative anomalies in the sacs position, and positive anomalies in the sacs position in the positive sum phase. And it agrees with Rosso and collaborators' results. Besides this sacs position, March to June and December, several months, you can see influence on Southeast South America with positive anomalies in negative sum phase and positive anomaly in negative sum phase and negative anomaly in positive sum phase. It's opposite signal for sacs position, for example. Using mounting this dipole, precipitation dipole in summer month. But this influence in Southeast South America is not restricted for summer month. You can see here in May, in June. This Southeast South America region also suffer impacts from sun. But in October, this is not correctly in October, sun has opposite signal in Southeast South America. Negative positive anomalies, negative precipitation anomalies in negative sun, and positive precipitation anomalies in positive sun. It's opposite from the other month. In summary of all these results, Southeast South America, part of Southeastern and Central Eastern Brazil, seems to be more affected by sun. However, some influences are different for each month, and there are also differences of these influences between some phases, and not always opposite. For the temperature, most months show positive anomalies affecting the aforementioned regions during negative phase and the opposite in the positive sum phase. However, the coverage area of these anomalies varies between months, among months. This is not correct, among months. February and December, the temperature anomaly dipole, with positive anomalies in Southeast and South America, negative anomalies on northwards in the sacs position, in the negative sum, and the January exhibits a completely different behaviors compared with the other months. And for precipitation, we can see a weakening of sacs during negative sum and intensification of sacs in the positive sum. It's current with previous works. And for Southeast South America, we have opposite of sacs signal, positive precipitation during negative sun and negative precipitation in the positive sun. And in October, the sun influences this region. It's opposite for the other months. And the big question is why? Why these differences happens? We need to understand why this difference exists, because this difference exists because there are differences of some impacting the circulation month to month. So it's not exactly, the influence is not exactly opposite between phases, and it's not exactly the same all the months. So it's quite complex. And what about the climate models? Can climate models represent and predict the sun? This is a paper analyzes some index from this red line is Marshall index. The other colors is index calculated from 20th century reanalysis, and this black one is the index calculated for using Bayes model for summer, autumn, winter, and spring. In general, they can represent the sun. The model can represent the sun, the trend, but the variability is different. Here, it's for some observed and ensemble forecast. This is from NSAP. The black line is observed. Here's the forecast. And here for the black line is observed, and this red shaded, I'm sorry, the yellow shaded, it's the ensemble forecast compared, and the blue line, it's the average of the ensembles. This is for compared the 7-day forecast with the observed, the 10 days forecast, and 4-day forecast. With 7-day forecast, we can see the line, the blue line and the black line is quite similar. We have a correlation, high correlation, 0.8, 0.85. But when we see longer forecast, the signal is usually lost. For here, we have a lower correlation, 0.6, and for that 10 days, it's only 0.2 correlates. We can see that the blue line and the black line, it's completely different from each other. So the sun predictability is low for climate scale. It's a problem. It's a it's active research area. How can the models represent better the sun in the climate perspective, the climate predictability? And for the end, we can see the trends and projections. Here's some results from Fogarty Marshall. There's a quite interesting paper, a review of all aspects of sun. Here there's a Marshall Sun Index. This is a 30-min running, and this is for season. For seasons. And this is for different models. This is for Marshall Index, Gongwang Index, and EOF Year 5. So using different techniques. For all these figures, you can see a positive trend, red values, positive trends for different indexes used. For all these figures, you can see clearly positive trends in the last decades in some. And here's a table from IPCC. This is for northern annular mode. This is for southern annular mode. Past changes, last decades. The studies of human influence of these trends. This is projections for near-term future and mid and long-term futures. For another annular mode, we can see some positive trends in 60s, but there's some variation in the last decades. But in the sun, we can see clearly the positive change. There is no robust evidence in the human influence of another annular mode changes, but it's quite established. The influence of greenhouse gases and ozone impact in the southern annular mode. The lower coverage of ozone in the last decades lead to positive sun in the stratosphere, and this signal propagate downward, and we have positive trends in the troposphere of Sun, mainly in austral summer, but also greenhouse gases impacts to positive trend in all seasons. And what about the projections? What about the projections? In near-term future, for another annular mode, the internal variability dominates, but in southern annular mode, all seasons except the summer, this positive trend project continues for near-term future. And in the mid to long-term future change, mainly if you look for pessimist scenarios, both northern annular mode and southern annular mode show positive trends for end of century. So, closing remarks about this class. Annular mode is a larger scale seesaw of atmospheric mass between middle and high latitudes in both hemispheres. We call southern annular mode or Antarctic oscillation for southern hemisphere, and northern annular mode or Arctic oscillation for northern hemisphere. We have some kind of indexes for some and none, but the most used is index EU that apply EOF in the monthly mean H anomalous poleward 20-degree latitude using 100 HPA northern for northern hemisphere and 700 HPN for southern hemisphere. However, this index using poleward to 30 degrees has shown interesting results because excluding the noise, the signal of tropical, the influence of tropics. The annular mode presents an active period. And what is this active period? The annular modes happens year-round in the troposphere, but the signal intensifies in the stratosphere, reaching the maximum in boreal winter for none, and November for some, for southern annular mode. El Niño favoring negative sun phase. The negative sun phase happens more frequently during El Niño phase, during El Niño year, and La Niña, in La Niña years, positive sun phase happens more frequently. There is a connection between PSA, sun, and SACS occurrence, and some influence different synoptic systems, jets, blocking, SACS, cyclones, fronts, etc. Some impacts on temperature and precipitation in South America, mainly in Southeast South America, parts of Southeast and Central-East Brazil. But, however, some influences are different for each month, and there are also differences on the influence between some phases, not always opposite. The climate models represent some configuration, but the predictability is low for climate scale. And there is a positive sun trend for all seasons in the last decades, except for summer, and it's happened because the low ozone and the high greenhouse effects. And the pessimist scenarios project for end of century positive trends for both some and none for all seasons. Okay, this is the references that I cited here in this presentation. And thanks, and any questions, you can also contact me by my mail, fernandavasconcelos@ideal.ufrj.br.
Thanks, Fernanda, for the wonderful and very informative presentation. I stop the recording now, and we are moving to the questions, doubts,
No.
comments.
Can
Okay?
you listen? Could you listen my cat screaming?
No. Oh,
We are having a scandal here. I'm sorry if you're
no problem.
disturbing the class a little.
I would have a question.